Okay, so the first problems that we're going to look at is if we are given a function f of x, how do we actually find what the inverse function looks, or what the inverse function is? How do we find f inverse of x? Well, to do this, first, often we're going to go through several steps, and these steps will be the same every single time, and we'll do 3 examples together. Then you'll practice much more later on your own. And so what you want to do first is, often we like to rewrite this as just y equals, let me use blue, y equals 4x minus 3. It's a little bit easier to deal with x's and y's than f of x's and x's. So we like to switch f of x with y. Then the inverse function, remember what the inverse does. It switches your x's and y's. And so what we're going to do is switch x and y. Switch x and y. So now we have x equals 4y minus 3. And then the final step is, now we want to isolate for y. Isolate for y. So to isolate for y, we can first add 3 to both sides. So we have x plus 3 equals 4y. And then divide both sides by 4. So divide by 4, divide by 4. And we have x plus 3 over 4 is equal to y. And that is the inverse function, but we want to use the correct notation. And to use the correct notation then, that would be f inverse of x. We did find the inverse function is replacing that y with the new y, which is the inverse of f. And so f inverse of x equals x plus 3 over 4. And that's it. And so these two functions are inverses. We have, and this is our final answer here. This is the inverse of that original function. So let's go through that process again with one more example, or 2 more. So we have here, we're going to replace f of x with y first. It's easier to deal with y's than f of x's to find the inverse. Okay, and then that's just like our setup step. And then the first real step is switch x and y. Switch x and y. I can write better than that. Switch x and y. So we have x equals y plus 1 all cubed. Then we want to isolate for y. Isolate for y. Okay. To get y by itself, how do we, what's the reverse function, or how do we undo this cubed? And to undo the cubed, we can take the cubed root. The cubed root of x is equal to the cubed root of y plus 1 cubed. And the cubed root of y plus 1 cubed is just y plus 1. So we have the cubed root of x is equal to y plus 1. And now we want to isolate for y, so subtract 1 from both sides. So we have the cubed root of x minus 1 is equal to y. The cubed root of x minus 1 is equal to y. And then finally, the last step is, again, replace y with our special new function notation, our inverse function notation. So that means that the inverse function of f is the cubed root of x minus 1. And the minus 1 is not part of that cubed root. We can like that if we want to. And let's look at one more example. We want to find the inverse function for f of x equals 5 over x. Okay, I'm actually going to make a little bit more room. Okay, so let's go through those same steps. We'll replace f of x with y. It's a little bit easier to work with. Not really doing much yet, but that's going to make this process a little bit easier. And then we can switch x and y. That's always the next step. Switch x and y. So we have x equals 5 over y, and then isolate for y. And when we isolate for y, we can multiply by y on both sides. So that gives us xy equals 5 when we multiply by y on both sides, and then divide by x, and y equals 5 over x. And then final step, f inverse of x equals 5 over x. Do you notice anything strange about this one? You may notice that the function is actually an inverse of itself. So the inverse function is the same as the original function. That means that this function is called a self-inverse function. It's a self-inverse function because the inverse of it is the same function inverse, a self-inverse function. It's not a big deal, but it's an interesting, there are a few self-inverse functions out there, and this is one of them. It has a specific name called the reciprocal function, but it is a self-inverse function.